welcome back. We saw in the previous module how to derive the bond pricing formula. And now in this unit we are going to take a look at three special cases of the bond pricing formula. And the first special case is when we have a bond that doesn't pay any coupon. So that's a zero coupon bond. Okay. In the case of a zero coupon bond, the bond doesn't pay any coupon at all, and therefore the bond pricing formula simply consists in the principal amount discounted back to present. Okay, so all the component that included the present discounted value of the coupons drops out, right? Because in this case C is equal to 0. We may also have bonds that pay coupons only and do not pay back the principal, and these kind of bonds are called annuities. Okay, so in this case M is equal to 0. Okay, so you're not getting the principal back, but we are getting a stream of coupon payments for the whole life of the annuity. And finally, if we set t to infinity, then we get a perpetual bond. It's a special case of an annuity, and this is basically a financial asset that pays coupons indefinitely, forever. Okay, so not only it does not pay back the principal, but it pays coupons forever, okay, as t goes to infinity. And in this special case, we call this kind of bond a perpetual bond. So let's go back to the bond pricing formula and let's rewrite it here. So the price is equal to the sum of S going to 1 to n t of what? Of the discounted coupons by the yield to maturity plus the principal amount discounted back to present. Okay, so what is this formula telling us? Well, it is telling us that the higher the coupon rate, the higher the coupon payments, and therefore the higher should be the bond price, right? Because we are getting, if the coupon payments are high, then we are getting a high interest income, so we should pay a higher price for that. By contrast, the higher the market required yield or yield to maturity, the lower the bond price. Okay, so and the yield to maturity is y in this formula. So the higher is the yield to maturity, the more you are discounting the cash flows, and therefore this ultimately lowers the bond price. Okay, because the present value will be lower of all the cash flows.